Okay, this should be a rather short lesson. Vertical sinusoid translation. Now we learned already how to translate graphs vertically. Like if I had y equals x squared, if I wanted to translate it vertically, make it go up or down, all I would do is add, if I want to make it go up 2, I just add 2 onto the end. So when we start vertically translating our sinusoid curves, which could stand for cosine curves or sine curves, all we're going to do is add a number onto the end. So let's look at this from your book. It says the graph on the left is a graph of our normal sine curve, y equals sine of x. When x is 0, the value of sine of x is 0. On the right, do you see how it all moved up? The center of the graph moved up 3. So this is just 3 plus this graph, the sine of x. So that's simply how you do it. So let's look at an example. We're supposed to write the equation of the two sinusoids shown here. So look at the first one. We're just going to write the equation of it. Now, it looks just like the normal sine curve, but if you look at it, do you see this dotted line is going across at 4 and not at 0? The normal sine curve, if you look at this one, see this normal sine curve? This is going through y equals 0. The one we're going to translate, you can see this line, the center line is going through y equals 4. So if we're going to write the equation for this line right here, it's just going to be, oh, and another thing, the amplitude goes from 4 to 6. So this is going to be 2. Remember we did this a couple lessons ago? So if we're going to write an equation for this line, and you can see it's a sine curve because it's going at 0, 0. It's right in the center. So we would just say y equals, we moved it up, the center line right here is at 4, so that meant we moved it up 4. 4 plus 2 sine of theta. You can see they have theta there, so we're using theta there. So this should be fairly easy. Let's look at this next one. This is another sine curve because we're at 0, 0, but it was moved up. Looks like it was moved down to 10. So we would write this one, and you notice this flipped. Instead of going up first, it's going down first. So we had a flip there going on. So this one would be y equals, it went down 10, so it's going to be minus 10, minus, and well, let's look at the amplitude. Keep that in mind. We went from 10 to minus 6. So our amplitude is 4. Right here is 4. So a couple things to keep in mind. So since it flipped, it's going down instead of up first, it's going to be negative 4 sine of theta. These are going to get rather complicated. When we start moving them left and right, that's when the complications start. Alright, let's try, let's go down to these. These are kind of small. You can see these are cosine curves because at the 0 mark it goes up and it's not right at where the lines intersect. So let's try this first one. We can see it's a cosine curve. That we can see. The center line is at negative 8. So we're going to write y equals, the center line, that means it went down 8, is negative 8. The curve didn't flip. It's going the right way. The amplitude is 3. From 5 to 8 is negative 5 to negative 8 is 3. So it's just going to be plus 3, and then you have to identify that it's the cosine of theta. So these aren't bad. Here's another one. This is another cosine curve because it didn't start at the 0, 0 point. And instead of going up, it's going down, so you can see that the graph flipped, so it's the inverse. So we get y equals, the center line is at negative 7, so we're going to have this one at negative 7. Since it flipped, it's going to be negative. The amplitude is 2, and it's a cosine of theta. And that's that. Okay, the last one we're going to do is, this one is arctan. So the problem says evaluate the arctan of the tangent of 35. So we need to find the angle, that's what this arctan means, it means the angle of the tangent of 135. So if we figure out what 135 is, let's see if I can move this over just a little bit so you can see it. Okay, there we go. This asks for the angle whose tangent is a tangent of 135. Now the thing to keep in mind is tangent is always between 90 and negative 90. So when they ask us, the tangent of the arctan is always between these two, between 90 and negative 90. So the first thing we do is we find the 135 mark, and you can see we have this 45-degree angle that's left. So they're really asking for the arctan of negative 1. So again, this asks for the first and fourth angle whose tangent is negative 1. So in order to get it into the right quadrant, we had to extend this down and make our triangle in the right quadrant. So this would still be 45 degrees right here. It's 45 didn't come out, see if I did it. And we know that this would be, if we did the tangent of this, it would be 1 and 1 and 1. So that's what we're looking for. So it would be negative 45 degrees. But just be careful when you're asked the arctan of a tangent, arctan of something, it has to be in these quadrants. If it doesn't end up being in these two quadrants, you need to just extend your lines down and put it in the right quadrant. So the final answer for this is negative 45 degrees. So that's it for lesson 47.